Hey, welcome everyone. Thank you for being with us. And before we begin today's conference, I'd like to take a moment to congratulate you, Mark, and everyone at Innovametric for an incredible milestone. 30 years of supporting manufacturers in their quality control process. That is quite an achievement.
Thank you, Anthony. It's been an incredible journey, and I'm so proud of what we've accomplished together. Here's to the next 30 years of innovation and excellence.
All right, absolutely. Let's get started. We're thrilled to introduce the exciting new features of PolyWorks for 2025. Get ready for an action-packed conference as we take you through what's new and transformative. Buckle up, it's going to be an exciting ride.
I always enjoy the yearly PolyWorks Conference Live, where I share my insights and observations about the evolution of digital 3D metrology processes with our customers.
So Mark, let's start this off. What is this year's topic?
Well, Anthony, we know that quality control teams produce crucial information for several departments within manufacturing organizations. For example, inspection projects, dimensional inspection reports, 3D measurement results, root cause analysis, and digital twins. And the important information they produce is often delivered through manual file exports and copies. This is what I want to look at today. While functional, this method does not address two major issues. One, the absence of a single source of truth, as multiple copies of the same information are stored in multiple locations. Two, such file-based processes are sensitive to human error and inconsistencies, since manual interventions are required in the data flows. So today, we will look at how we can replace those manual file exports and copies with digital thread technologies that can deliver 3D measurement data digitally to all stakeholders within a manufacturing organization.
You know, Mark, when I hear the word thread, it makes me think of my mother's sewing machine.
That's a good analogy, Anthony. The thread in a sewing machine ties pieces of fabric together to create clothes. In a similar way, a digital thread ties together the multiple software applications used by a manufacturing organization to create an interconnected space where data can flow digitally.
Can flow. Okay, and how are we going to explore this idea?
It's quite simple. We will first introduce digital threads and their benefits and explain the technological components that are needed to deploy a digital thread for 3D measurements. Next, we will present the major benefits that the digital thread brings to the internal operations of quality control teams. Then we will present technologies that extend a digital thread for 3D measurements beyond the quality control team to deliver 3D measurement data digitally to all data consumers across departments. Finally, we will explain how we intend to extend the global reach of our digital thread through business partnerships, expanding the interconnected space where data can flow digitally.
Data can flow digitally. Awesome. Well, I think we're ready. Let's start right off. Can you help us understand the concept of digital thread?
Sure, but first, we should talk about the need for data exchange. Manufacturing organizations legitimately strive to use best-in-class solutions from multiple vendors for different fields of expertise. As they rely on multiple software applications, manufacturing processes must, therefore, ensure that data flows from one software to another. Historically, manually triggered file exchanges were the main method used to exchange data between two software applications. I'm sure many of our attendees can relate. Let's say you want data from software A to be imported into software B. You would export the data from A to a file on disk. Software B would then be used to retrieve the file exported by A and import the data it contains. After the import operation is completed, one could review the exchange data within A and B and conclude that it is the same. So, it looks like data exchanges could be done successfully by using files. Could anything go wrong? Well, file-based data exchanges do not typically pose a problem when the exchange data is guaranteed not to change in the future. In quality control applications, however, data changes all the time. Consider these 4 examples. A measurement device under maintenance is not available. You'll need to create a new piece measurement template and share it with the team. The design team has updated the CAD model of a part. You'll have to update the inspection project of that part. A piece was measured and some measurement results were not computed. You'll have to retrieve the inspection project used for that piece and adjust measurement parameters to calculate the missing information. You're investigating a manufacturing issue. You'll need to evaluate additional dimensional controls on a batch of previously measured pieces. It's problematic when something is changed in a software application and information from this application has already been exported to a file and possibly shared with others.
Definitely. Clearly, the file is no longer valid and colleagues are at risk of using incorrect or even incomplete information.
Exactly. You end up having multiple versions of the same information, which leads to errors, time losses, and process inefficiencies. This compromises the search for truth at the heart of quality control. The technical solution to cope with data changes when exchanging information between software applications is the digital thread.
And how does this digital thread work?
With the digital thread, the 2 software applications that exchange data are interconnected. Considering our previous example, software B would use an application programming interface, or API, to contact software A. In addition to transferring data between A and B, the digital thread would also store a link to software A within B. This link represents the key difference between a digital thread and a classical file-based exchange. It allows us to dynamically reconnect software applications. For example, software B could regularly interrogate A to check if the information it holds is up to date and obtain the most recent information if necessary. So, a digital thread is much more than a digital data exchange. It is a powerful mechanism that ensures there is a single source of truth by propagating information changes seamlessly between software applications.
Thank you, Marc, for this insight. I see that the digital thread technology preserves data integrity. And without it, you can never be sure to what you see in front of you is correct, which is a major concern. So how can we create a digital thread for 3D measurements?
Let me use an analogy that everyone can relate to. Years ago, we got our water from various sources, manually or through small deliveries. Today, our water is automatically collected and filtered for quality, stored in centralized locations, and distributed 24/7 to consumers everywhere, automatically for numerous uses unimagined years ago. And we would never go back. Similarly, you need 3 components to deploy an end-to-end digital thread for 3D measurements: a universal metrology software platform, data management on a central server, and digital connectors. Now, let's look at these components in more detail and see how each one contributes to the infrastructure for digital data exchange. The digital thread for 3D measurements starts with the adoption of a universal metrology software platform. A universal platform that provides a universal metrology workflow allows quality control teams to perform all the planning, execution, and analysis tasks of a 3D measurement activity using the same tools and interfaces, regardless of the type of 3D measurement technology involved. Even more importantly, it provides the technology to store all inspection data and results within a single unified file format, eliminating the need to export data to neutral files to aggregate results produced by multiple measurement software. Then, to avoid breaking our digital thread by copying files onto a network disk, we need to upload all the 3D measurement data produced by the universal platform to a central data management server. Storing all 3D measurement data on a central server represents a true paradigm shift, as managed data is no longer trapped on local hard drives. The quality control teams don't even need to explicitly share their data anymore. Once an inspection project is uploaded to the data management server, it can be consumed immediately by anyone with the right permissions. And finally, to maintain the digital thread up to the consumers of 3D measurement data, we need digital connectors that leverage the data management server's application programming interface to bring 3D measurement information digitally within the software tools they use, without relying on manual file exports and copies.
Okay. Mark, do we always need all three components to deploy a digital thread for 3D measurements?
Yes, each component is essential. The universal platform ensures that a single file format is used for all 3D measurement data, while the data management server and digital connectors eliminate manual file exchanges.
Now, many of our attendees work as part of quality control teams, and they are probably wondering, why should they consider deploying a digital thread for 3D measurement? Because change always means time and effort. So could you elaborate on the benefits that a digital thread delivers to quality control teams?
If you're a quality control professional, a digital thread for 3D measurements will have a huge positive impact on your work. It starts with 3 benefits that will personally save you hours every week. With a data management server in place, all the 3D measurement data files and folders are managed automatically. So you will no longer need to save inspection projects on a disk or maintain a complex structure of folders to hold your data. You use a search engine to retrieve measured information and filters to quickly find what you're looking for. It's the end of manually browsing for files. Finally, you can review 3D measurement data from any device or any location using a standard web browser or mobile application, so anytime, anywhere access. As for the team benefits, they also represent a real game changer for quality control teams. Several customers who adopted the PolyWorks digital thread have reported to us that they can do twice as much work with exactly the same team. With a digital thread, you can share common project and piece properties for all inspection projects to ensure high-quality metadata for root cause analysis. You can manage inspection project permissions to control who has access to the data and what can be done with it. And you can work concurrently within a single inspection project. For example, multiple operators can measure different pieces, while one colleague reviews measurement results and another prepares a piece measurement template for a new measurement device, all at once. And there's more. You can also share data through hyperlinks instead of copying large files manually on disk. Launch discussions within inspection projects to accelerate problem-solving activities, and digitally integrate data from multiple sites and suppliers. With a digital thread for 3D measurements, suddenly all the hardware, software, and people are interconnected and data flows digitally. And that gives teams across your organization a real boost.
Okay, wow. This really sounds like a digital revolution in the making.
Absolutely. And it's out there being used by major manufacturers. Of course, once a quality control team has tasted the benefits of a digital thread, there is really no going back. Take, for example, a quality control manager I met during one of my business trips. He rightly complained that his team could not do their work as they were constantly bombarded by requests for reports from engineers and managers working in other departments. Pieces were accumulating in the storage room, and the team had no time to measure them. After seeing my digital thread presentation, he was beaming as he realized that the digital thread would allow colleagues from other departments to access the data and find the information they're looking for by themselves, freeing his quality control team members from their traditional role of data gatekeepers. So, The ultimate benefit of a digital thread for quality control teams is that they can focus on their measurement work and become high-performance specialists.
High performance. I'm sensing, Mark, that the benefits of a digital thread for 3D measurement extend beyond quality control teams. Is that correct? Am I right?
Yes, you are right. And I'm sure our attendees caught that as well. Beyond quality control teams, typically 5 to 10 times more colleagues from different departments like design, manufacturing, quality assurance, and production need 3D measurement information as part of their work. A digital thread for 3D measurements can change their lives too. Of course, the digital thread technologies needed by data consumers are different from those used by quality control teams.
And I'm sure everybody's asking, why is that?
Well, quality control teams and consumers of 3D measurement information use different software tools. The primary tools of quality control teams are 3D metrology solutions. This means that when we develop a digital thread for quality control applications, we have control over the whole software implementation. The scenario is different for consumers of 3D measurement information. While they could use 3D metrology solutions on occasion, these are not their primary tools. They use other enterprise solutions, for example, CAD software and product lifecycle management systems, quality management systems, reporting and analysis software such as Power BI and Excel, and many other solutions. So the technical challenge to implement a digital thread for data consumers is different compared to quality control teams. We need to develop technologies to digitally interconnect multiple third-party software to PolyWorks, so data consumers can access 3D measurement information from within the software they use.
And everybody's asking, and including myself, how can you achieve this?
Well, two key technologies are needed to implement digital connectors between PolyWorks and a third-party solution. Firstly, an application programming interface, or API, to allow a third-party solution to talk to PolyWorks and exchange data digitally. And secondly, uniform resource locators, or URLs, to keep links between the two solutions. As we pointed out earlier, an API and URLs are all that we need to implement a digital thread between two software applications. PolyWorks offers both technologies and uses them to develop digital connectors.
And talking about digital connectors, how many off-the-shelf digital connectors does PolyWorks offer today?
We have already developed 10 digital connectors. 2. Review 3D measurement results within a standard web browser or mobile phone application. Import CAD models of parts and assemblies from two product lifecycle management systems. Prepare complete 3D measurement plans using 3 professional CAD solutions and import them within PolyWorks. Create data summaries, graphics, and automated workflows within Excel. and publish compelling dashboards and reports using Power BI. In addition, our customers have access to our API and URL technologies to develop their own digital connectors, to interconnect our digital thread to any solution they use, including customized solutions dedicated to their processes.
Okay, so are 10 connectors enough to cover all the applications that might need access to 3D measurement data?
Our existing connectors cover a wide array of applications and processes, and we plan to add more connectors in the future as we identify new business opportunities. However, the use of 3D measurement data is expanding, and the number of applications that could benefit from it is rising as well. So we think that the task is too big to solely rest on our shoulders. This is why we have decided to partner with software companies to allow them to develop and commercialize digital connectors that exchange 3D measurement information between PolyWorks and their own solutions. It was natural for us to take this decision, as we had already determined that PolyWorks would be an open solution.
And I'm just curious, as you are right now, do you have examples of software companies that are currently developing digital connectors for PolyWorks?
Yes, we are collaborating with IQA, a developer of manufacturing quality management solutions, who's building 2 digital connectors. The first connector allows PolyWorks Inspector users to accelerate inspection project creation by leveraging IQA's automatic ballooning software. And the second connector interconnects IQA's analysis and reporting tools to PolyWorks Data Loop to obtain 3D measurement data from the single source of truth. Let's watch a short video introducing IQA and how their solution interacts with PolyWorks.
All right, dear guests, let's play this right away.
At HiQA, we're passionate about simplifying and automating manufacturing quality. We help companies like yours streamline collaboration, both internally and across your supply chains. Now, through our partnership with Innometric, we're taking this mission even further. Together, we're weaving a digital thread that connects your quality and manufacturing teams, empowering them to work smarter, faster, and with greater accuracy. Let's take a closer look at how this partnership transforms the manufacturing quality lifecycle. The process begins when a customer sends you a new part. With HiQA software, your engineering team can instantly balloon the drawing and create a detailed inspection plan for each manufacturing operation. But how do you share these quality requirements with your CMM programmers? Introducing HQA Connect. This powerful tool bridges the gap between your teams. Now your programmer can open an interactive balloon drawing, select characteristics, and automatically sync them to PolyWorks Inspector. With this seamless integration, measurement plans can be created 2 to 4 times faster, all while maintaining complete data integrity. On the shop floor, operators execute these measurement plans to collect data, which is stored in PolyWorks Data Loop, your centralized source of 3D measurement data. Finally, HQA Connect closes the loop, automatically pulling data from Data Loop to populate key reports like FAIs, PPAPs, and SPC, saving your team hours of manual work. This partnership introduces a new level of automation and interoperability that's never been seen before in manufacturing. What does that mean for you? Increased productivity, fewer errors, and automated reporting. With HQA Connect plus PolyWorks Data Loop, your people, processes, and data are connected like never before, enabling you to deliver high-quality products faster and more efficiently. If you'd like to learn more, we invite you to visit our website or reach out to your HiQA or Innometric Group representatives. We hope that you'll join us in building the future of manufacturing quality together.
Wow, this improved process to extract dimensional information from 2D drawings and inject it into PolyWorks Inspector looks very, very effective. Have you already received customer feedback?
Yes, some customers said they would save hours of work. Others mentioned days, and that's for each inspection project.
All right, great. What will be the next example?
I'd like to introduce you to Autoform. They develop powerful simulation software for sheet metal forming and other manufacturing processes.
Mark, I don't see the relationship between simulation and 3D measurement. Would you please elaborate?
Simulation is an important technology that can predict the behavior of manufacturing processes without actually fabricating anything. With simulation, you can adjust several manufacturing parameters and find out what works best for you at a minimum cost. Now, the output of simulation software is very similar to 3D measurement data. It is typically a polygonal model that describes the surface of a simulated piece. And PolyWorks Inspector is really an outstanding tool for analyzing a simulated piece and determining how close it is to its corresponding CAD model. So, the PolyWorks digital thread is ideal for sharing these analyses within engineering teams. Let's hear from Autoform how our solutions can be efficiently combined.
Well, there you go. All right, great. Let's have a look.
Ladies and gentlemen, I'm Olivier Le Tertre. I'm the CEO of Autoform. Autoform has been leading for 30 years the automotive industry in the forming on body-in-white domain. Every car you can see in the street have been using our solution to optimize the process. Our mission is at the process engineering phase to optimize the best scenario to avoid rework on problem at the prototype on production phase. Inometrics, for 30 years, have been leading this digital 3D metrology domain. Customers are using Inometric PolyWorks solutions to perform the quality inspection of parts subassembly at the pre-production phase. The foundation of our partnership is to change this workflow and to make this quality inspection a virtual quality inspection based on simulation at the process engineering phase. By doing that, customers will enjoy three main benefits. Number one is they will detect quality issue 12 to 18 months before start of productions. Number two, we will connect the quality people with the process engineers, and that can reach to a better quality achievement. Third is you will reduce dramatically the cost of rework. So just today in Autoform domain, body-in-white and stamping, we have demonstrated that by increasing the digitalization process, we can make our OEM save 5 million euros per project and per year within OEM and suppliers. And the good news is that we don't need to wait for new product. We have today the Autoform portfolio and Inometric portfolio that can bring that value tomorrow to our customers. So let's increase the footprint and the value we can bring to our common customers. Thank you.
And I'm sure you're wondering, and we're going to get that answer right now, what are the key benefits of using Autoform simulation technologies for manufacturing organizations?
This type of technology reduces the number of tooling and assembly process iterations, which lowers costs and accelerates the delivery of new products. With the integration of Autoform simulations to PolyWorks, engineering teams will have more detailed analysis of deviations between simulated and nominal dimensions, which will further improve simulation efficiency.
Now that's really awesome. Do you have one last example?
Yes, our longtime German business partner, Duvet 3D, is developing a virtual clamping plugin for PolyWorks Inspector. It allows deforming a digitized model of an unconstrained sheet metal piece as if the piece was physically clamped by using simulation software. With this new tool, our customers will no longer have to build checking fixtures for individual sheet metal parts, accelerating their inspections and lowering costs.
I'm curious, just as our audience is, to learn more about this application. So let's hear about it right now.
For over 25 years, we have been the exclusive distributor for PolyWorks software in Germany, Austria, and Switzerland. Close cooperation with Innovametric is key for us, and together we have optimized numerous customer processes. Our strength lies in enhancing the powerful PolyWorks ecosystem, taking full advantage of its digital thread for 3D measurements to create customized solutions for greater quality, efficiency, and cost savings. Currently, we are developing a virtual clamping integration into PolyWorks Inspector. My colleague Tobias, who runs our customer solution department, will tell you more.
Our automotive customers ask us for an innovative solution of checking pressed sheet metal parts in PolyWorks. Sheet metal needs to be constrained in order to get meaningful measurement results. Currently, they use a dedicated physical clamping fixture for each part. This is not only expensive, but also takes up valuable storage space, not to mention the time-consuming and error-prone setup processes. And this is how it works. The part to be checked is positioned on a flexible, universal holding fixture, so one fixture serves all parts. Using any 3D scanner, data is acquired in PolyWorks and optimized for simulation. With FEM software such as Autoform Assembly, ANSA VCA, or Hexagon Simufact, the component is then virtually constrained to its RPS points, and the FEM software calculates the reaction of the component to the virtual clamping forces. The result of the EM simulation is a virtually clamped STL that can be used in PolyWorks just as real scanned data, a perfect basis for evaluating the part and tool quality.
With the integration of virtual clamping in PolyWorks, we have combined existing technologies to offer a cost-effective and flexible solution that greatly simplifies and optimizes this clamping process. The benefits are clear. First, reduce the need for expensive physical clamping fixtures. Second, remain flexible in the choice of measuring device, holding fixtures, or FEM software. With virtual clamping, problems are detected early before they lead to costly production errors. All information can be shared with PolyWorks Data Loop in a browser-based manner so that all engineers have access to the information that they need instantly. Our customer Porsche Leipzig is already virtually clamping their parts and checking them in PolyWorks. Ongoing proof of concepts for other OEMs show time and cost savings of up to 60%. So stay tuned for more information this fall.
It is impressive to see metrology and simulation software seamlessly working hand in hand.
I agree, Anthony. These three examples demonstrate that with like-minded business partners and open solutions interconnected through a digital thread, we can maximize the value of 3D measurement data for manufacturing processes. The sky is the limit.
The sky is the limit. All right, we've arrived at the last segment of this year's keynote presentation. Let me recap what we've discussed today. We started with an introduction to digital threads. We've learned that they use application programming interfaces and links to interconnect multiple software applications digitally without relying on manual file exports and copies. We then presented the three technological components needed to deploy a digital thread for 3D measurements: a universal metrology software platform, data management on central server, and digital connectors for third-party software solutions. After that, we highlighted the benefits of the digital thread for quality control teams. Now, freed from the time-consuming task of managing files for themselves and their colleagues, quality control teams can leverage digital thread technologies to focus on their measurement work and become high-performance teams. And lastly, we've shown that digital connectors allows data consumers from other departments to bring 3D measurement information within the software they use. Innovametric currently develops 10 digital connectors and started partnering with other software companies to add more. Is there anything missing, Marc?
No, that covers everything. But I'd like our customers to focus on a key outcome of the PolyWorks digital thread for 3D measurements. It ensures that there is a single source of truth for 3D measurement data. This is a real concern for our customers. For example, professionals worry about scenarios where two different versions of a part's CAD model circulate within their manufacturing teams, and their company mistakenly manufactures two variations of the same part. Fortunately, technical solutions have been developed to prevent these kinds of situations. Another source of concern is that multiple variations of a part's 3D measurement results circulate within an organization. Why worry? Because 3D measurement data is actionable. Based on the dimensional feedback you obtain from 3D measurements, you make important decisions that have impacts on multiple levels. So you want to make sure that the data used for each decision is correct. And the surest way to achieve this objective is by deploying a digital thread for 3D measurements. I'm sure that this subject has interested everyone listening to some degree, whether you produce or consume 3D measurement data. I have really enjoyed sharing my insights with you. Thank you for listening. In parting, I invite you to engage with our teams to learn more about the huge benefits delivered by the PolyWorks digital thread for 3D measurements.
Marc, thank you for sharing with the PolyWorks community.
Thank you, Anthony. Thank you all.
All right, let's continue with the live session showcasing the new features of PolyWorks.